welcome to my very first flipped video and for my flipped classroom. Today we're going to be talking about rational and irrational numbers, or the real number system. Okay, and what you need for today is you're going to need this light green foldable, that's just a single foldable that I handed you out in class, and the hot pink foldable. And it has a bunch of little ones inside that I will later kind of explain what each one of these individual tabs does. Okay, they need to be laid out like this, closed, I guess. And you're also going to need, for later, some glue to glue them in. And possibly a calculator. You can use your cell phone to check my numbers and that sort of thing. I just really want to show you the difference between the two numbers. Okay, so again, this foldable is over real numbers, and so that needs to be your title, real number system. Okay, so we're going to be talking about real numbers, and you need to kind of set them up like the way I have them, the light green one on top, the pink one on bottom, okay? And again, I'm going to wait until the end to glue these in, but I'm going to kind of the little collective, a little arrow to say that we're going to be talking about this whole thing. These are all real numbers. Okay? Every number we talk about is a real number. Now, real numbers are everything that you've probably dealt with in life and probably will deal with in life. You will, in high school, start dealing with imaginary numbers, which is the opposite of real numbers. But everything you've dealt with up until this point is all real numbers. Okay? And it's going to be one of these two categories. Okay, the two types of real numbers that exist are irrational. That's what's going to go on this green one. Irrational numbers and rational numbers. I'm going to put an S on this. Numbers. Okay. Now, you've dealt with probably one irrational number. You have dealt with rational numbers your entire life since you were a nitty-bitty one and you were counting for the very first time. Okay? So this is where you're very comfortable. This is where you're not as comfortable and you haven't learned much about. But this is where in 8th grade we kind of focus a little bit, but you can't forget the things that you already know. Alright, so irrational numbers. This is a thing you're not probably that familiar with. This is what is 8th grade. Okay, let's define what is an irrational number. Okay, it is any decimal that, and there's two ways you can be irrational, okay? It can, and this is just to kind of show the next thing, it is a decimal that never repeats. So it goes on and on and on and on. And you might remember one that we've talked about in class before that goes on and on and on and never ends. And we'll talk about that in just a moment when we do examples. And so it has to never repeat. That means it doesn't eventually go into a pattern, or it never ends. Okay, those are the two criteria that it can be. It can never repeat or it never ends. And usually these coincide, okay? Most numbers go true to both of these. Alright, let's write some examples down. And I'm just going to write EX, for example, on what kind of numbers we're talking about. Okay, if you remember, there is this symbol called a square root. Square root symbol. It is on your calculators. We talked about it last year. When you have one of these calculators, not your good graphing ones that you'll later get, but remember it was second, this number right here, this x2, and you get the little square root symbol. You can't see it very well in the video, and I'm sorry. but any number that doesn't repeat. So I'm going to tell you 2 is an irrational number. And I'm going to press enter, and I don't know if you can see it very well, it's kind of hard to see, but it's 0.141421, and notice it's going on and on and on, and it will not ever repeat. So that makes the square root of 2 an irrational number, because look, it never ends. It's going to go past even this number as long as the calculator will allow. There are several of these. Pretty much that's anything that's not a perfect square. And yes, this is some remembering from last year, but perfect squares are anything that ends up perfectly, like the square root of 16. When you put the square root of 16 in, you get a nice whole number. You get 4. Well, if I do the square root of 10, look, it's another one of those. I get 3.1622, and it goes on and on and on. And it will forever go on. So the square root of 10 is an irrational number. Pardon me, guys. Okay, the other thing that we have talked about a lot, we even celebrated a whole day, that is the famous number that never ends, is pi. Okay? So just put the little pi symbol. If you kind of want, you can say approximately 3.14. But I'm doing the wavy equal lines because remember, this goes past. It goes on and on and on and on. So these are some things. We're going to be working a lot more with irrational numbers if you're confused. But this is just the intro to what an irrational number is. Remember, it never repeats and it never ends. Okay, let's jump into what we do know, that is review. Okay, so if you were like, wait, this is scary, well, here we go. This won't be scary. This is just simply review. Okay, we're going to be dealing with rational numbers. But the way I want to do this foldable is I want to open it up to where all the tabs are open, like this. That means the green one's going to lay all the way across, okay? And because this is like nesting circles. Everything that fits inside this circle fits inside the blue. The green fits inside the blue fits inside the yellow sits inside the pink, and all of them are real numbers. So we're going to start with the smallest, the simplest, the easiest numbers, probably the first things you ever learned, which are natural numbers. They are the counting numbers. So right around here, I want you to write on this side, write the counting numbers. Okay, they're the counting numbers, like 1, 2, 3, 4, 5. Okay, and it goes on and on and on. I'm going to even do the little dots to say, yep, it's going to keep going. It's 6, 7, 8. It goes forever. And these, they're the counting numbers, but their math term, and we're going to write it on this front side right here, these things are called natural numbers. These are just your counting numbers. And I'm going to probably refer to them as much by counting numbers as I am natural numbers. But the true math term is natural numbers. Okay, so all natural numbers, 1, 2, 3, 4, 5, are also whole numbers. Okay, and you know what whole numbers are. They have no pieces and they have no decimals or fractions attached to them. They are simply like $1 or 10 or 100. Those are whole numbers. So we're going to write the definition of what a whole number is, and it's going to be all natural numbers including 0. Oops, I kind of ran out of room. And this is including 0. Or you can just write the 0, okay? So, for example, it's any of the counting numbers. So any number that you can count. 100, 1,000, 0, and then 1, any number. Pretty much any number you can think of. And that's actually what I want you to do. I want you to think around this outside, and I'll probably help you out with this first one, I want you to write any whole number that you can think of. Okay, everyone knows, or y'all should know, that 5 is my favorite number. Well, 5 is a whole number, and I want you to put 3 examples along the outside. You can use my 5 and then pick 2 others and write them on the blue, just around the yellow. Okay, or the green, excuse me. Okay, now once that is done, and you can pause this video at any point so you can think of some whole numbers, I want you to write whole numbers on the back side of this tab. Whole numbers. Okay, so 2 tabs are done. We have talked about whole numbers and then natural numbers. The only difference between a whole number and a natural number is 0. He's the special guy that is the only thing different between a natural number, which is your counting numbers, and whole numbers. Okay, now this one you're also very familiar with. You talked a lot about this last year. Okay, it's integers. And since you kind of get the drift of how we're doing this, on the front part here, we're going to write integers. Okay, that's the next section. Okay, let's write the definition. An integer is all whole numbers and their opposites. And their opposites. Okay, opposites. Opposites means the negative, right? So let's write, like, make sure you give yourself a little note that it's all the negatives, okay? So, integers, this part right here, is all whole numbers and their opposites, okay? So, I'll give you some examples. Positive 1 is an integer because it is a whole number, but what's the opposite of positive 1? Well, it's negative 1. That's an integer. It's not a whole number because whole numbers can't be negative. But integers can. They can have the positives and the negatives. So 6 is a whole number and its opposite is negative 6. Those are all examples. I want you to come around the outside here and write at least 3 examples. Okay? Again, I'll give you a hint on one. Negative 5 is an integer. But, hint, possibly 5, its opposite, is also an integer and could go around this yellow part, okay? So, around this yellow part, don't get on the blue, but on this yellow part, I want you to write 2 other examples. This is how I'll know you completed it, okay? And if you want to give yourself a hint on integers, write a little negative sign. Because remember, it's the positives and the negatives, okay? It can be both. And it is both. All right. And then this is what we talked a lot about last year. This is all rational numbers, okay? So that includes integers, that includes whole numbers, and that includes natural numbers. What other numbers have we talked about in your entire math career? Well, you've talked about fractions, you've talked about decimals, you've talked about whole numbers, you've talked about percents. That is what a rational number is. So it's all integers, whole numbers, and percents. So let's get some. So it can have. So there can be fractions. There can be percents, which I'm going to do this symbol right here. Percents. There can be decimals that repeat, and this is where it gets a little bit interesting. Decimals that repeat. Because let's hark back. What made an irrational number is a decimal that did not repeat. Decimals that repeat are okay. So that is probably the hardest part and what we'll be practicing. So don't get scared if you're like, wait, I don't remember this. So here, let's do some examples. All right, a fraction. I'll do a great one. 1/2. That's a perfect example. Okay. Now, 15%. There's a percent for you. Now, I'm going to write this one down, 1/3. But then I'm going to show you on a calculator that it's one of those decimals that repeats. Okay, notice I wrote it as 1/3. That's a fraction. But how do we change fractions into decimals? Well, y'all remember this is just a division problem. So we're going to go in our calculator and go 1 divided by 3. There it is. And it becomes this. And I hope you can see this. It's hard to see. But 0.33333. Notice it never ends. So, but the fact that it can be written as a fraction or a repeating decimal, it's okay. It's rational. It hasn't jumped into the irrational world yet. Okay? So, this was our very quick, and this is, remember, how to write repeating decimals. This was a really quick review on types of real numbers. Okay, I'm going to ask you to glue these in and have it ready for us when we start class. We're going to go over a few more things to make sure that you truly understand the difference between rational and irrational numbers. And then we're going to get into ordering those numbers. This is why you have to know the difference, is because we have to be able to place them in the right places, order them, and if you don't know what kind of number they are, it makes it harder to order them. So, the two types of numbers you have are irrational, and they are usually square roots of numbers or the wonderful number pi, or rational numbers. And there are all these numbers inside this foldable are rational numbers, but they lower into different pieces. So the types of rational numbers are integers, whole numbers, and natural numbers. Okay, so when you come to class the next day, I expect this to be glued in and ready, and so we can talk some more about real numbers. All right, bye guys, get some sleep.